Hi, welcome everyone from sunny Amsterdam, from Codam. For those that are for the first time with us to Codam Masterclasses. Codam Masterclasses are sessions where professionals in the field run a deep session in a specific topic related to software engineering. Today we are talking about clean code together with Vinny. Hi, Vinny.
Hello.
Hey, thank you for joining today and for willing to share your knowledge and try to, contribute to the further development of our students. You are a Ph.D. software engineering guy, right?
Yeah.
For which company are you working these days?
Now I work for Flow Traders here in Amsterdam for almost 2 years. Yeah.
And previously?
Previously, I worked in ASML in Eindhoven. I worked in US, and in Brazil, I also worked there. But yeah, I've experienced different countries.
Yeah, fantastic. Because something that is for sure, like no matter from which country you come, your code has to be understandable by everybody, correct?
Exactly. Yeah. Indeed.
So that's why we created this session. With no further ado, I would like to give you the word. And maybe you'd like to give at the beginning a disclaimer how you came across Codam and what kind of examples you would be given throughout the presentation.
Yeah, for sure. I have slides for this, no worries.
Fantastic. Take over, please.
Thank you very much for the kind introduction. Hello, everyone. I'm Vinicius. I'm originally from Brazil. Yeah, I've studied computer science bachelor like back in 2004, and then I've continued on the research part. And yeah, I have a long path of experience in terms of research and also development and academia. I also wrote a lot of software, and there I started learning to write clean code, and also in the industry, different companies. And it's a topic that you never know everything, you never learn everything. So it's like continuous learning. And I want to share a bit of my knowledge with you guys, and I hope you enjoy. So a bit about me. So as Victoria mentioned, I have a PhD in computer science, and my research back then was applied to microelectronics. So I was researching algorithms, efficient algorithms for synthesizing circuits, as you can see like examples of tools on the right-hand side of the screen. And this involved a lot of mathematics, computer science, more specific C, C++, and clean code because, yeah, collaborating with other students, different universities. So the clean code was very important to ensure a smooth collaboration back then. And then I moved to the Netherlands. After a while, I worked in Eindhoven ASML in the field of microelectronics also. And almost 2 years ago, I changed my career path to do something different, different challenges. So I'm working in the trading industry, and it's high frequency trading. And it's a very challenging industry because we must write low latency code that are codes that must respond within fractions of a second. So less than a microsecond, that is 1/1,000,000th of a second, sometimes in nanoseconds. So it involves a lot of computer architecture knowledge, language knowledge in terms of C++ and C. And yeah, it's very interesting. And above all, also it's very important, clean code capabilities, and because there are tens of developers working in a big code base. So clean code is a very, very important topic for most of the industries. And the one that didn't figure out yet, they're figuring out in a hard way. So I hope that you enjoy the presentation, and I can convince you that clean code is a very important trait for a software engineer. So a disclaimer that is important to mention. So I try to prepare a presentation using examples from students that are publicly available in GitHub, GitLab, and other platforms. And why that? Because I wanted to bring examples that are in your real life, in your student's life, things that are not too far away and too abstract from what you have been working and studying. So there are examples from the beginning and from the middle of the curriculum. So I think everyone can benefit. For those that already done the project, they can think about it and revisit the projects that you've done. Think how could you write it better, and for those that for the projects that you haven't done yet. So it's a good opportunity to learn something, and when you reach those projects, you write and try to practice clean code, because it's something that you're going to improve with practice. So like I said, I brought these examples, and it's the purpose of learning only, is not to shame or something. It's just for learning. And I try whenever possible to keep and to maintain the Codam norms into account. But in some cases, because of space limitation, I don't follow them. And also sometimes I don't show all the functions in the slide, but I mention them also because of space limitation. So without further talk, let's go directly to what is clean code. So this is a very nice cartoon that's a bit old, but it's also very new, because it represents like how can we measure objectively what is clean code. And of course, there's no way to objectively measure clean code, but according to this cartoon, one way to measure the quality of your code is a number of WTFs per minute, because a code must be clean, not for you, but also for the readers, the reviewers, right? So in this cartoon, for example, you can see two doors. On the left-hand side is, for example, when you submit your code for review in a company or in Codam or whatever. And the code is clean, it's a good code. So of course, people might, there's always something that people stop, think a bit, but it's just some small things. Overall, the code can be easily understandable. When you have a bad code, a smelly code, like on the right-hand side, so people really don't understand. And I'm sure that every one of you already saw this kind of code. You look at the code, you don't understand what the author was trying to achieve, what the code's trying to achieve. It's very confusing. So the objective here is that you write code that's going to go in the first door, the good code. So let's then jump for an example. So this example, is this a clean code? And it's an example from Cube 3D project. And yeah, if you stare at it, the name of the function doesn't say much, and the arguments also don't give much hint, because the names are not clear, and you can see a lot of repetition, a lot of like magic numbers 0 to 55, and repetition in these lines here. You see it again here and here. So yeah, as a conclusion about this code, the intent is not clear. You can understand, but it takes some time. The namings are not good. The name of the function, the variables, it's too many responsibilities being taken care in this function. So there's a lot of code duplication. And for those that haven't figured out yet what it's trying to achieve, so basically it's reading from a file the color, for example, from the ceiling or from the floor, and is an RGB format that is comma separated, and you have 3 color channels, right? And the author is trying to like read the number from the line, check if it's an integer in the range of 0 and 255 to see if it's valid, and otherwise it prints there's an error in the column. So you see that this function is quite confusing, but we could do better. For example, I've exercised myself to improve it, and this is the first step. So first thing, this is the high-level function in line 45, and I split in 3 parts. And the high-level function now has only one responsibility, and you can see, sorry, you can see that there are many variables that are carefully named, and they are constants because they are not supposed to be changed in this function. So I clearly define how many colors I'm working, what is the separator between the color channels, RGB as a comma. And then we take the line, the input line, and provide it to function ft split. That's going to split that string into n parts, trying to find the commas. And then from this split, we check if the number of splits is 3, because we want 3 color channels. So that's why I create this variable, has 3 color channels. It's very explicit of what it represents, what it means. And then there is a variable called valid, in which checks if it has 3 colors, and each of the color channels are valid, and it represents a valid RGB. I'll note that I use Thibault here because C doesn't have a type Boolean. So we can define this using a type def for integer. And why it's better? Because it's more expressive. It reveals the intent that it's representing a yes or no question, right? True or false. So that's why it's important to use Boolean or Thibault or the created type for making the reading of the code easier, right? And then as you can see, I created another function called isValidColor, in which it just receives this split line. And then I have 3 lines here, one for checking if the red is valid, another one for green valid, and another one for blue valid, right? And this function is going to return true if all the 3 are valid. So you see that the names are very expressive, and you have no trouble understanding what it's trying to achieve. And lastly, this function isValidColorRange just checks if the string can be transformed into an integer, and if it's within the range of an RGB 0 to 55. So that is what this function is trying to achieve. So as you can see, each function has a specific responsibility, and the functions are small, well named. So this is an example of how you can rewrite code with a lot of duplication into a clean code with good variables, good names, right? Other things that we could change, for example, is the name of the function, because sol check doesn't say much. So for example, check if valid RGB, I think it's better. But of course, there's no secret sauce. You can find your own way, your own names. As long as it's expressive, it's fine. There are different ways of writing the code. And another thing that I don't like about this function is that it's doing too many things, in the sense that if it's not valid, it's also printing error and exiting. And ideally, this function should just be responsible for checking if the color is valid and return a Boolean. And then whoever calls this function should do the appropriate action. So I would also further reduce it to return a Boolean, and then we just return if it's valid RGB. So you can see that the code now is very clean, almost natural language, because it's variable for everything, and it's very clean for anyone that reads what it's trying to achieve. You're not gonna waste a lot of time thinking about what the author was trying to achieve or what are the possible side effects. So the main characteristics of a clean code are the clear intent. So you look at the code, you look at the function prototype, and you clearly and rapidly understand what it's trying to achieve, because it is expressive, has meaningful names. The logic, as you could see, is much simpler, straightforward. So simple assignments, or at most simple Boolean equations. No duplications. You don't surprise the reader or the user of your library, because you are doing what you promised to do from your prototype. And yeah, it's much easier to maintain, right? So with this, let's go to the outline of the presentation. We'll discuss a lot about clean code, and of course, I divided it into some topics. So first, we're going to talk about naming, then functions, comments, some implementation patterns that I brought some examples and some techniques that you can use to improve your code that are very close to your daily life in the projects that you do, and finally the conclusions. So first, about naming. So I'll provide a lot of guidelines that you should take into account when you write your code. So the first one is don't mislead the reader. This is very important, right? So if you look at this function prototype, it's a function that returns a sharp pointer. The name is strjoin_fr. The parameters are const char pointer s1 and s2. And when a parameter is const pointer, we assume, or the caller assumes, that the data pointed by that pointer is not going to be changed because it's constant. So it cannot be freed or it cannot be changed. But if we look at what the function actually does, it does something different. So it's misleading the reader. What it's actually doing is doing a string join, calling the str string join, and then freeing the first parameter. And to achieve that, the author cast the char pointer into a non-const because the compiler was complaining. So as you can see, if the warnings are enabled, this is what Clang gives as warning. So you're passing a const parameter to a void pointer function. So this is important. You should look at your compiler, and it's going to help you a lot. Never disable warnings or ignore it, because they are always something important. There's a nice phrase that says the warning from today is the error from tomorrow. So really, really look at your warnings and don't ignore them. So here, clearly, the author just, yeah, I'm going to cast a char pointer and resolve it. So what the author should have done, maybe receive non-const parameter, and I would also suggest to also free both or rename the function, but be more expressive in the intent. We saw that in this function, the writer of the function was promising one thing, like saying that it would swap the two things, but it actually doesn't swap. It just copies one of them and deletes the other, and frees the other. So the author is not doing what it promises. One important thing that I want you to have in mind for those that didn't see the disclaimer. So due to space limitations and also because of clean code point of view, sometimes I don't follow all the norms. That doesn't mean that the code is wrong. It just means that I don't follow the norms. So yeah, for example, declaring a const variable in the same line is the way that should be done. So just to make this point. And yeah, if you go for different companies or different schools, they're going to have different styles, different guidelines. So don't be too attached to specific formatting, because as soon as you go somewhere else, there's going to be a different formatting. So just you follow the format, but don't be biased and don't be guided freely only by that. Right? There's just an addendum. Okay, so the next guideline is about attach necessary information. So if we look at this function, and you see that I've highlighted many things, and the name of the function is called sort3. And the parameter is tnums double pointer a. And this function is from push swap project. And as you can see, there are some variables t and b that don't say me anything because it's encoded in some letter. And for the reader, it takes a while to understand what is the intent of the author. And they actually mean top, middle, and bottom. And what the author is trying to achieve here is receiving a stack A, with 3 elements only, and trying to find the way to sort it. So it tries all the combinations, so to say. And I put a comment here on the side to help explain what it's trying to achieve in each of the conditions. So for example, in the first condition is checking if this is the top of the stack. So if the top of the stack is bigger than the middle is smaller than the bottom, and the bottom is bigger than the top, right? So to achieve the sorting of this stack, it just needs to do a swap of the 1 and 2 and write SA, right? And similar things happen in these other 3 branches here. And as you can see, like there are many problems with this code, like repetition, necessary information, and this kind of thing. So I've worked to improve this code, and I managed to reduce it a lot and find a better way to check if how to sort a stack with 3 elements only. And one thing to have in mind is that clean code is not something that you write in the first shot. No matter if you are junior or senior, nobody writes clean code in a first pass. It's some iterative process, right? So it's completely fine that you flush your ideas, put your ideas, write code like this, or even worse, that doesn't matter. It's completely fine. What is important is that as soon as you understand and absorb the information, after you put them write the code, test it, and so on and so forth, that you improve it later. So you revisit and say, how can I change it? How can I make it cleaner? Because then you already in a point of good understanding of the code. So first thing, yeah, the name of the function and this kind of stuff. So what I did, the first thing was changing the name of the function called sort stack with 3 elements. So there's no surprise in this name. It's saying what it does. And the parameter name also stack, or can be double pointer or pointer, or doesn't matter. Depends on what you want to achieve. And what important is that you have a type saying that is a stack, not tnums or something, because it doesn't say anything. And then the variables should not be tm and b, should be top, middle, and bottom, because they're descriptive. And you can initialize them and should initialize them as constants, because they're not supposed to be changed in the function. So you assign the stack num to the top, stack next num to the middle, and so on and so forth. And these variables are not going to be changed, right? And this is good because it also facilitates the reader understanding of the code, and also helps if you accidentally change some variable, the compiler is going to say that you are trying to change a constant variable. And any kind of error that the compiler gives to you, you are saving headache because you are finding an error at compile time and not at runtime or debug time. So then the next step of this function is get the maximum of the 3 elements in the stack. I'm not going to show to you this max function, but you could write it easily, for example, with 2 if conditions or something. But you get the meaning that it's just getting the maximum, the biggest element of the stack, and putting in a number. And then create a variable called moves, so that we're going to return the number of movements that it took to sort this stack with 3 elements. And then there are just 2 steps to be executed. First, as you can see, the function called is move element to bottom, stack biggest. So from this line, you see that it's clear what it does. You don't even need to look at the function. It's just going to take the biggest element and move to bottom, right? And then in the next line, swap top if needed. Could be swap top middle if needed. That's also fine. But then you can see that it's much simpler. I'm going to show you the functions, but you don't even need to look at them to understand what it's trying to achieve. So if you have a stack like that, you're just going to move the biggest element to the bottom and then swap the middle on the top if necessary. So, and these functions are like that. So move element to the bottom, it just takes a stack and an element. And again, 2 well-named variables for top and middle. And then we check if element is equal to top, and then we can call a function called execute command, for example, that would take a stack and the command that we want to send, like an enumeration, RA. And then this function is going to be responsible for doing the rotate in the stack and printing the screen, right? And if the element equals to the middle, then it's going to execute a swap and then a rotate. And then in this case, returns 2 movements. And then swap top if needed. Again, we declare top and middle to make it explicit. And then if the top is bigger than the middle, then we just do a swap. So you can see that this function refactored, so it has simplified logic. The name, it's a very explicit. The function and the variables are very, they are revealing their intent. And every function has one specific responsibility, and we move from high level of abstraction to low level of abstraction. Like this function doesn't need to know how it's gonna swap something, or it just execute high level steps of the algorithm that we are writing here to sort a stack with 3 elements. Then another question, another guideline, sometimes questions that come into mind, like how long should be a name, right? So one important quote from Robert Martin, called Uncle Bob also, that is a very nice phrase, like long descriptive names are better than short mysterious name. So it's better to be long and descriptive than short and don't say anything like TMB, right? So, and also important that when you name your functions, the names should be a verb or an action that you're going to act on your parameters if there are some. So for example, like you can have a function called create player and takes a position. So it's saying what it does. I'm creating a player and returning it. Or compute sprite angle, taking a player position and sprite position. Or process next instruction that takes text and instruction. So these are kind of examples of names that you can use for your functions. And also pay attention to the name of the parameters that also help the reader understanding what you're trying to achieve, right? Of course, not too long. For example, if you would merge the two functions, for example, create player and compute sprite angle, then it's a warning sign would be that you are concatenating two different things like create player and compute sprite angle. So this is a sign that you will be doing too many things in the same function. So you should split them in two functions. But names like this, or maybe a bit longer, they are fine and they are very good. They help the user. Other things about the variable names. So attach necessary information to understand those variables. So for example, if you have duration, it should put the unit there, like milliseconds, or the size in megabytes, or the angle, for example, in Cube project. Say if it's radians or if it's degrees, put in the variable name, not in a comment, because comments rot and don't help the user. So every information that is important, you should put in the variable. Unless you cannot do it, I'm going to show an example later. But the vast majority of the cases, you can represent it in a variable or extract it into a function, right? Other thing about the short names. You can use short names sometimes, in general for short scopes or for loop variables. So it's common to reserve I and J to iterate on arrays or matrices, or XY to iterate on maps. But other than that, I strongly suggest not to use single letters. And for example, in this function called sum elements, it returns it receives an array of elements and the size. And clearly, what it does, it's sum the elements of the array. So I declare two variables, the int, that's going to be the index, that's going to iterate on every position of the array. And then I create a variable called sum, not x, not s, not anything, sum, because I want to say to the reader that this guy is going to keep accumulating for the elements. So we just visit every element and increment and assign. So, and then return the sum. So you see that in this example, I have a variable named sum and one single letter variable for the loop, which is fine. It's important to say that acronyms sometimes are okay to be used and abbreviations, but only things that are known in your field on some specific area, or like common abbreviations like str, doc, or msg, like message. But pay attention to that. If you are in doubt whether you should abbreviate or not, I would not abbreviate, because it's better to be explicit than like mysterious. But just to point out that some acronyms and abbreviations are okay. There's no problem with that. Okay, let's talk about functions. So one important guideline is that a prototype should reveal the function intent, like I said before, and now we're going to explore a bit more about it. And also the function name should be a verb and action. So if we look at this function prototype, it returns an integer and it's called a which x amount, and takes a double pointer nums and the range pos. From this prototype, I could not understand the function, and I think that most of you also cannot. Because of the naming, because of the parameters, nothing helps the reader. And if you look at the function, this is the function body. And what it's trying to achieve, it has a stack, and it receives an index of an element on the stack, assuming that is from 0 top to n-1 bottom. And it's trying to move the element to the top with the minimum number of elements. So if it's in the top bottom, and then it's going to do rotates, right? So it checks if the position is smaller than half of the size of the stack. Then it's cheaper to do number of rotates to bring the element to the top. Otherwise, it do the number of reverse rotates. You can see that the code has some problems, the name of the function, the parameters, the name of the variables, taught, these kind of things, they can be improved. So for example, first I would change the name of the function to be move element to top. So there's no surprise. I'm moving element to top, I receive a stack and an element position. So it's much cleaner and much clearer what is achieving, right? And then to achieve that, I refactor this function, and you see there are only const variables, well named. So here, first I store in a variable called stack size, and I'm not showing the function that's going to compute the size of the stack, but you already should know it should be trivial, depending whether you implement with linked list or array or whatever. But assume that I have a function that computes the size, and I store it in the size, stack size. And then I have another variable, Boolean, that I'm going to check, like as the name can see, is closer to top, right? If you even don't look at the Boolean equation on the right-hand side of the assignment, you know what it's doing, like it's checking if it's closer to top. Simple. And to do that is just the same logic that the previous code did, is just check if the element position is smaller than the stack size over 2, right? And then I declare two other variables. One called number of rotates, that is just an assignment to element position. But why I created this variable name? Because I want to tell the reader that this is the number of rotates. This represents the number of rotates, right? And the same for number of reverse rotates, that is stack size minus element position. And then the logic is just simple if else, and you see that you read like a text. If is closer to top, right? There's no surprise. And if it's closer to top, it's gonna call a function called execute command n times or something like that. And then you pass a stack, the command that you want to execute, like RA, and you pass the num of rotates that we calculated previously. Otherwise, we call the same function passing RA and number of reverse rotates. So you see that the variables are all constants. They are well named, no matter if it's just a simple assignment. What we want here is not to write short code, it's not to write mysterious code, is to make the code easy to understand. Remember, you write the code for humans, not for the computer. But the one that's responsible for mapping to the computer is the compiler. You have to write code that is understandable by other human beings. Another one is avoid deep nesting, too much indentation, right? So you have like why, if else, right? And in general, a good guideline is no more than 2 levels. I would say 1, but in this case, if you are iterating on a 2D structure like a matrix or map, it's okay. So function is from cube, and it is allocating and initializing the sprite, although the name of the function doesn't say anything, and the variables also don't reveal that, because the user, the writer of this function, uses I to index the sprite, which is not intuitive, and iterates on the map, Y using J and X using K. So it's not intuitive for the reader. And it also allocates some sprite here and has to handle that, which also pollutes the code and is doing things that shouldn't be done in this function. And then, of course, it's going to visit every cell in the map and check if it's equals to 2, which is a magic number for me, a magic character, and should be an enumeration or should be something that will represent it well, right? And then if it's a sprite, then it sets the position, and note that it increments the index of the sprite here, which also is confusing. You're saving one line, but you are not being expressive. So how do we refactor this function? First, we can change the name like get sprites, init sprites, or something like that, right? Second, create a variable called sprite count or sprite index or something like that in this direction. That's more expressive. .I is reserved for indexing. And then for the map, you could use ij, but I prefer to use yx because the map is more like a yx. So that's more intuitive, at least for me. But you could use ij if you prefer, or ji. So the first thing that I've done, I've moved this allocation to another function. I don't show it, but it's just I just copied that code to another function called malloc sprites, and it returns an error I return. So I'm not doing this function doesn't know how to malloc sprite, doesn't need to know how. And this is another function responsibility. And then this function continues iterating on the map, and on every position of the map, it just calls another function called setup sprite and continue incrementing the x and y. So that's just it. Very, very straightforward. And the role of this function is just iterate on the map and calling a setup sprite. No more responsibilities than that. And then the other functions like setup sprite would be doing what was done before in the same function. Like it checks if it's a sprite, I'm not showing here, but could be just a function that compares if their character is equals to 2. Single line function, expressive, and possibly reusable because you would be able to reuse the different parts of your code. And then note that I also create a function called set sprite position. I don't do the position here in the same function because it's responsibility for someone else. So then it sets y and x, because if we resolve to change or something, this is going to be isolated here and possibly reusable by other parts of the code if we want to set up sprite position on different parts, right? So then we are avoiding deep nesting. We are not adding another level like with another if condition. So in general, I suggest don't do more than one level of nesting unless you are doing a two-dimensional visitation on a map or on a matrix. And if you do, follow this idea. Then another thing that I already talked is one level of abstraction per function. What it means is that the function has too many responsibilities and also alters between high-level information of what you are trying to achieve to how you achieve that. Like in this example, it's from Philosopher's project, and the variables are also not very well defined. So in this condition here, you see that it's allocating, although it's not very clear what it's trying to do, but a very complex condition here. And then it's trying to init some text. And then it's very confusing logic. And also here, note that this I is to save line. That also doesn't make sense. And here, complicated logic. And also another complicated logic. So this function comprises too many responsibilities and mixed level of abstractions. We are dealing with allocation, we are dealing with initialization of a thing, we are dealing with different things, right? How could we make it better? So this is the refactory init philosophers. So it's a small function and it calls 3 other functions. So the first one I called malloc resources, in which I just copy pasted that big Boolean equation that was inside an if, and I put into lines because it's more readable, of course. But that's not the role of this function to know how to malloc resource. You just call someone else, and if it returns false, then I return error malloc, right? And this one is just mallocing the philosophers, then mallocing the fork, and mallocing the thread mutex. That's simple. Don't even, the reader can decide, yeah, malloc resource, I'm not interested to know what's doing. But in this old code, you need to understand, because you cannot, the writer is not being kind to the reader that it can stop at some point. It needs to read everything so that it can understand, because there are so many things happening. It's hard to stop at some point. Like here, I don't want to know how it malloc resource. As long as it mallocs, I'm fine with that. And then pthread mutex unit, that is from C. And then setup philosophers, I also just refactored a bit that code that was in a complex logic. It could be improved a bit more, but just to give you an example. So first, you have the num-philo here that I created just to avoid using this big phi, the reference parameter, the reference number of philosophers, to make it easier. And see that I abbreviated number, num. It's fine, because everyone knows that's number. I don't always do that. Sometimes I do num, sometimes I do number, depend on the situation. And then I create a variable called philo ID, because it's the identifier of the philosopher, and it starts with 1 and goes up to number of philosophers. And then this while we're just gonna visit every philosopher and call another function that was also being called by the other version that I showed you. That's just set up philosopher, and it reassigns the ret, and the while loop's gonna get out as soon as the return something goes wrong with setuping of the philosopher, right? Or if it succeeds, it goes up to the end as initializing all the philosophers. So as you can see, this function now, it's very high level. It just do 3 steps, and every one of the steps is responsibility of another function that is just doing one thing, one type of task, right? Another guideline is don't repeat yourself. It's very important guideline, because duplication is a maintenance hell. It makes the code hard to read, hard to reason. If you duplicate the code, they might be close to each other or far apart. And if you need to change some part, you might forget to change the other parts and imagine that someone else changing the code. So don't repeat yourself. And it's very, very common source of bugs. So in this example from push swap, is a function called push, 2 functions, pair of functions called push A and push B. Push A, it's just takes the second argument, the top of the second argument, the second stack, and put it into A. Like it's called PA, if I remember correctly. And push B, it does the opposite. Takes the top of A and put it into B, right? So as you can see, this code is very, very, very repetitive, right? And in addition to that, it's not very descriptive because the order of the parameters is a bit confusing. And but it's doing exactly the same thing, with the exceptions that the variables are on the different side of the assignments, but it's exactly the same thing. And this could be refactored. And surprisingly, I wrote a code that is bigger, which is fine, right? So the high-level function is called execute push. It could be something else. It's not a perfect name. It's a good name, execute push. And the parameters also help to understand from to. So it's going to push from something to something. And it has just 2 steps, right? First, it calls a function called pop from a stack that just removes the top element of the stack and returns it. And then it calls a function push that has the destination stack and what I'm pushing, right? Very simple. And then the pop function receives double pointer stack, returns a stack node. Here is represented by a linked list, as you could notice. And then if the stack is empty, you don't have anything to do. Otherwise, you take the top, fix the pointer, adjust it, and then set that popped element. The next is null because now it's like a node that is pointing to nothing, and it returns it, right? And then we would push this element using this function that receives a stack and an element. And of course, the element is null, you don't do anything. Otherwise, you set the next of that element to the head, pointing to the head, the previous head of the stack, and then adjust the point of the head of the stack again. Right, so very, very straightforward. And the advantage is that here, for example, these pop and push functions, they are common functions for a stack, and you'd reuse for other functionalities like maybe rotate, maybe swap, maybe something. So we took code 2 functions that were repeating themselves and put into more expressive way, refactored in functions that do only one thing and are potentially reusable. Right? Okay, now comments. Let's talk about bad comments. So this is an example that I took from one student, philosophers. And you can see that this docstring format here, it's saying not more, not less than what the function prototype says. So it says that init args, that's the name of the function. It says number of arguments, argc, argv, pointer to the structure field. So it's not saying more than what the function prototype already says. So this kind of type of comment that is just for sake of commenting, right? And this is common. Companies do that. And this is a really, really, really bad habit because first comments rot, right? So if someone comes and change the function, change what it's doing, most of the time people don't change the comments because compiler don't interpret the code, the comment. So, and sometimes people are lazy or something like that. So avoid, or better, don't do this kind of comment just for sake of comment. So if we erase these 13 lines here, doesn't change anything to understand the code what it's trying to achieve. It's just there because, yeah, the author added. So don't do this kind of code, this kind of comment, just for sake of comment. Another example of now good comment. I brought this example that I created the comment, just try to illustrate, it could be done differently. But we have a function here called compute sprite angle that receives the player position and sprite position, right? And so first we have a variable called sprite to player distance, in which the intent is clear. So it's just getting what is the distance X and Y between the sprite and the player, right? And then I have two variables. One is angle radians. See that I'm attaching information here, and then angle degrees, and then it adjusts the angle in case it goes over 360 and it's fixed. But yeah, that's not the point of this discussion now. So you see that there is a function called arctangent that belongs to libc to calculate the arctangent, the reverse of arctangent. And then I pass a minus here. And then the comment, it explains why, right? So the comment says, compute the sprite angle in the Cartesian plane. A tangential function considers y to be positive in the first and second quadrants, like here, and is negative in the third and fourth. But in that project, the y was positive in the third and fourth quadrant. It's like flipped plane, right? That's quite common for games. So therefore, sprite to player distance y has to be multiplied by -1. So of course, I added this drawing here just to be a bit more fancy. It facilitates to visualize better, but could be removed. But note that this comment is really adding some information that cannot be understood otherwise. You could add the comment here on the top. Also, maybe there will be a way of creating a variable, but I think in this case, it's justified adding a comment just to understand. And even for you, like 2 or 3 months after looking at after writing a project, to look at the minus, like, why did I add this minus sign? So that the comment is helping. So general comment guidelines, most of the times they are not needed. So if it helps to understand messy code, refactor it, prove it, and remove the comments. Don't describe the intent in the comment. Rename better, refactor, put functions, break down your code. Make it easy to read. Comments just are there to make the things worse. Also, to explain bad names, you can put a good name for the variable, like sprite angle radians, rather than angle and then a comment radians. So angle radians. And as an example, as the example before, like sake of commenting, also don't do that. And when they are needed, so when of course the information cannot be expressed in the code, or if it can, it would be too complicated. So then you can add a comment or to warn the user for some side effect of your function or something. That is fine. Other than that, don't add comments. So as you can see, much more reasons, and I could even elaborate more, to do not comment than to comment. The fourth part of the presentation. So it's called implementation patterns. I named it that. And the idea that I had before even coming with a name for this session was to bring some common patterns, some strategies, simple strategies, and some not so simple, but you're gonna see, that can help you, especially in your the beginning of your career, and also gonna help you like in your future career when you become medium senior engineer. A lot of suggestions that are gonna make your code easier and cleaner, right? So the first one, we start with prototypes and header files. So this is a header file from a project libFT.printf. I think it's your second project, if I remember correctly. And the objective of the project is reproduce or implement part of the function printf from C. Of course, some of the things you don't need to do, but the signature of the function is the same, right? And what you should deliver in this project is a library, static library. And a library is composed, of course, a header file and a .a file. So when the user is going to use this library, Then it includes the header file so that you can see the function prototype. And when it's compiling, linking the code and make file, for example, it adds this .a so that the compiler, the linker knows where to find the function definition that's on that library. And most of the time, the library providers don't provide the source code with the library, of course, to do not disclose proprietary information, or maybe something different, but yeah. So a library API, a library interface, in this case, the API is your header file, your function declaration, should contain only what you intend to expose to the user. And for this project, clearly, we want to expose only this function in 9.12, ftprintf. The rest is just auxiliary functions to help achieve the goal, which is fine. What's not fine is to put in this header file. Also some internal struct. You don't expose this to the user, because if you expose in your API, then the user gets access to it and you have to maintain it. Maybe you don't think about it now, but it's a very important thing. And also for separation of concerns, every file, every header source should be responsible for doing one thing, like taking care, for example, of conversion to integer, conversion to string, or whatever. So how it should be done? The header file should be, like, I put the name here to facilitate in the comments, just to understand that this would belong to the header file, ftprintf, that would have nothing else than the prototype of the function ftprintf. That is what you make available to the user. And that should be in your header file. No matter if it's a library or if it's just a header file, your own project or something. Put in the header file just what is intended to be exposed, right? And then the .c file would include, of course, the printf.h and maybe other header files that would have functions that would be responsible to converting to integer or printing string or whatever, formatting, things like this, right? So then in this way, we're not exposing the internal functions to the user. And you could have other functions, other header files, like you could have a header file ftprintf str, for example, in this, that I took this example. And then in a header, you would have the function that you would expose by this pair of header source file. And you have the body and the .c. And maybe, for example, if you have an auxiliary function, like insert padding, for example, if it's just like private to this, to help to achieve this goal here, and you don't want to expose it to the external world, then you put only in your C, .c, like static here, and then it's not going to be exposed. And the same here for ftprintf int, and then we would do the same thing. So note that every header file will have only the function that you want to expose, and you are partitioning to different header files. Each pair of header file and source file is going to be one responsibility, one thing, right? It's a very important thing. Okay, let's talk about another thing that I see a lot is the famous use of magic numbers. So I see it a lot, not only in the code from the students, also in the companies that I've worked. A lot of people do this, and it's a very, very, very bad habit. So this function belongs to a cube project, and it's called ftpush, although it should be ft key pressed or something like that, because it's handling press of a button key. And as you can see, it's trying to check what is the code of the key to do some specific action. And I had to Google because I didn't know which operational system it belonged to, and it's macOS. I didn't know what's the key 13 or 1, or I have no idea what is that. So the user should have put those keys, named those keys using an enumeration. For example, as here, you could create an enumeration called key, and then you give names, good names. Key A is called 0, key S called 1, so on and so forth. Key left arrow, key right arrow, key shift. So it's very, very expressive, and probably you would need to use in different parts of the code, so there's no risk that you were using 13 and then you miswrite it like as 14, and then some maintenance hell is hard to debug. So it's defined in one place only, right? And it would be easier if you wanted to have your program that could support like maybe Mac and Linux, and you could do some tricky thing to have numerations for different operational systems, for example. But that's not the focus now. So then I renamed to key pressed. I created another function to handle the player direction. That's other responsibility. And maybe here I just keep like, see here, very easy to read, key equals key shift, or key equals P. Then it would call a function called change camera speed, pause game, something like that. And handle player direction would check if the key is W, if the key is S, A, or anything. So you look at the code, oh, okay, okay, W is 13, but I didn't know what was 13 before, right? So don't use magic numbers, create enumerations, or if there's not a given set of things, but just a magic number in your function, like for example, the speed, you just create a variable called the constant speed or something like that. But don't use magic numbers. And yeah, it's gonna help you a lot in improving the readability of the code and also maintainability. Okay. Another topic is about conditions. So extract conditions into functions. Conditions are very, very important. And they are source of bugs. Because if you, miswrite it, mistype it this, or erase it this, then everything goes to hell, right? And it's hard to debug. So these are complicated conditions, and they don't say what they are trying to achieve, and they are repetitive. You see that the same pattern here, here, here. It's from Minishell, and it's trying to see it's dispatching, like checking if the line is a CD, the input command is a CD, it dispatches to parsing CD, otherwise to PWD, otherwise to echo, which is fine way of dispatching. What I don't like in this function is the conditions that are complex, and we can improve it. So what I was trying to achieve is drawing a string and compare, and then checking if after the end of the string there is a space or no car, because it's the end of the command, right? And here, because the command is 3, it's 3, 4, and 4, right? But it could be better. We could create a function isCommand that I will explain in a second. And then here we just call if isCommand, if isCommand, if isCommand, right? So easier to read because it's more like fluent, and there's no repetition. So all the logic needed is inside here. And I also, of course, carefully renamed the parameters input and command name. And first thing that I do, I calculate the command size, again, creating a constant variable, because I think it's more expressive. Saying command size is better than reading strlen command name in the middle of some other things, right? And then I have 3 other Boolean variables. The first one is matches command, right? And as you can see, it's very expressive. It's just checking if the input matches the command. So it's the same logic that the author was doing. Input, command name, command size, but rather than hard coding the command size, I get it from here, and then checking if it's equals to 0. Then I have 2 other variables here that are going to help explain what I'm trying to achieve in the final Boolean expression. So first is ends with a space. So I just call function ft is a space that you implemented in the first project, and passing the last character of the command. And then of the input, sorry. And then I check if it ends with null. I check if the last character is a null car. And then why that? Because it facilitates the logic here. That would be more complicated if I would put directly input equals null car or something. Then the logic is like matches command and either ends with space or ends with null. I could create other variables or another one, but I think this is enough. Of course, you don't need to like make the perfect code. This is good enough, in my opinion. It's already expressive. There is no repetition. You can already understand the intent. So you need to find a good balance. But yeah, you're gonna keep improving it with the practice. Still about conditions. So the idea is that you should encapsulate and simplify complex conditions like the ones that you see here. So it's very hard to understand what it's trying to achieve. And this function is part of a printf project. And it receives a string, and it tries to find if there is some forbidden conversion from the name of the function. Okay. So the first condition is okay, is a condition to stop the while if the index of that string, that specific character at that index, it's either nucar or if it's a percent sign formatter. So the first thing that it's doing, it's checking if it's a conversion specifier. Like a what's the name? A flag character. Sorry. So it's plus, minus, hashtag, whatever. So if it's that, it increments the count here, and then it checks if it's a lowercase alphanumeric, and then if it checks if it's a lowercase alphanumeric and is different from one of the non-conversions, like to char, to string, to pointer, to integer or whatever. If it's different from that, it returns null and frees the string. And then there's another condition that checks if it's an uppercase character, and it compares with the uppercase flags. So the function, the conditions are big, are hard to read, and they could be merged somehow here. And that was the task that I tried to achieve with this function. So we're factoring 4 functions. This is the top level, still called search for forbidden conv. And this loop here still has the same condition. It stops when ends when reaches nucar or formatter, a percent. So the first one, the first function that I created is called isValid flag character, right? And what it does just do is a single line. It just checks if the character is equal to one of the flags that we are expecting. So a single line function, which is fine. It's very expressive. Doesn't make our code slower. Forget about it. The compilers are very, very, very efficient. So don't worry about calling a function or something. The compiler in the end is going to inline this function, or it's going to. Compiler always does a good job. So don't try to be smarter than your compiler. So so this is called checking if there's a valid flag, and if it's a valid, then increments the index that I call I rather than X, because it's more common. And then if there is no valid conversion specifier for that character, then it returns. So what is valid conversion specifier is another function that it checks if it's alpha. That can be anything upper or lowercase, A to Z. And if it's flag, right? And the function is flag, it just checks if the character is equal to one of the flags that you, the conversion flag that you want to use. So then you see that there's no repetition, it's more expressive, and every function, small functions, one thing only. So I really encourage you to do this, break down your code into small functions, good names. So when it's possible, you can use a variable rather than a function. And note that these functions could also be used in other parts of the code. So this makes the conditions much simpler to understand. Still in the realm of conditions. So this function has a complex conditions, as you can see, that is highlighted. And it's called ft_name_check. And it's from cube. And what it's trying to achieve is checking if an argument or a file name and the next it matches, it has this extension, like for example .cub or something like that, right? And it does in a weird way with complex conditions. So first it checks the size. So this is function computing the size. And then it checks if the size is bigger than 4, because otherwise there's no way to match the extension. And then it compares in backward fashion 1 by 1, like from the argument -1 with extension 2, argument -2, extension 1, so on and so forth. Then it checks there's the dot. So it's a very weird way of checking extension. That could be done differently. First, I rename the function to has_valid extension. That is more descriptive, returning a Boolean that is just a type def for int, but it's more expressive because it's like yes, no question, right? And then I put the first file name rather than arg, because arg doesn't say anything, and extension rather than ext. I think extension in this case is better. So the first variable is called file name length, also descriptive variable, just simple assignment, but it's more descriptive. Then extension length, also str length for the extension. And then another variable called extension begin that is going to see what is the index of the possible extension begin in the file name. So it gets what's the file name size. So if it's 10 and then extension length is 4, so it's going to take 10 minus 4. And if the file name is length is less than or equal the extension length, then there's a problem with that. Otherwise, you just do a string compare for the file name at the index of the extension begin that we just computed, compare with the extension itself, and it should be equal to 0 because we want the extension of the file name to be the same as the extension that we expect, right? So it's simpler. The condition here has been improved and rewritten in 3 different parts. It's just a string compare, but we created some constant variables to describe one by one what we're trying to achieve, and the reader can read like linearly the code and understand it. Right? Now again, talking about types, enumerations. I talked about before magic numbers, but I want to stress again about like really use them, enumerations. And I found a lot of examples, bad examples in the code about using like magic numbers, so like -14, -15, and so on and so forth, here to represent an error for a parser, and I think it's Cube project. And for example, here, the writer of the code could have created an enumeration called tr code or something like that, and then define what is the name for each error code. So then you would define all the errors that you expect in a readable way, like GNL parse error, resolution error, texture, invalid texture, so on and so forth. And I didn't replace here, but I could have replaced it, and makes it much easier. So the idea here is to sell that it's very important that you use enumerations to represent things that are otherwise represented with magic numbers like error codes, and would make easier to read, like rather than -14, missing resolution or missing texture, something like that. Okay, about types. Enumeration is a type, and structures are types, and integer, double, all these are types. Integers and doubles and char, they are primitive types from the language. And when you use structure and you're creating your custom type, your own type. So I encourage you to create your own types and auxiliary functions to help operate on that type. So I created a small example. This is not from any student. It's just something custom made, just to try to explain the idea of how you can create good types. And this in the context of Cube project, for example. So we have a player, and the player has a position and a direction and a speed, for example, right? And for the direction, we can create an enumeration because we have, for example, 4 possibilities of direction, up, down, left, right, and we clearly define it. And then we can have a position, if it's a bidimensional map, X and Y, right? And a player that's going to have a position, a direction, and a speed. And some might ask, okay, why don't I use X and Y in the player directly and I use position? There are many reasons for that. So first, you should bundle together things that belong together. So there's not much sense having X and Y separated because they mean something together. They mean the position. So it's more expressive. Other reasons are, for example, if you have a function that receives a position like X, Y, and if the function will receive X and Y, it's very easy to make a mistake and you swap the parameters, you pass Y and X, and the compiler is fine because the types are still the same, are valid. So these are very hard problems to find and to debug, test. So, but if you have a type position and your function receives a position and you pass a different type, like an integer or any other type, the compiler is not gonna like it. It's gonna give a compilation error saying like you were trying to pass a type of integer, a type integer for an argument that expects a position. So it helps you finding these kind of mistakes at compile time. That's much easier to fix then compared to problems that you have to debug, or if you, let's say, that you're in a company and then there's a problem in production, then you need to, sometimes you have limited access to debug logs, or you have to have core dumps and things like that. So the more errors that you can capture at compile time with the help of the compiler, the better. And creating types helps you in this direction to avoid making mistakes of swapping the same type, the order, and when you pass non-compatible type, the compiler is going to tell you. And for example, for this player type, we could have like two functions to be like in the same header file that you would distribute to like player, that would operate on the player. For example, create player. That is a function that's just going to receive a position, a direction, and a speed, right? And what it does, it just initializes each of the attributes. Maybe not all of you have seen this syntax before, but it's possible to do like this, designated initializers. So dot attribute name, like position, dot direction, dot speed, and then you assign to the each of the arguments that you're receiving, and then you just return the player. So then your code is going to be like smoother and easier to read. And if you need to do some other logic to create the player to allocate something, we're going to see in the next slide, then it's going to be encapsulated in one place, right? And you could also have a function called move that acts on the player. That's why it's a verb, and that's a player and direction. So just an example that would check what is the direction and update the coordinate, incrementing or decrementing with the speed, for example. It's just a simple example, but just to show you how you can do that, for example, in your Cube project or in a similar project. Still about types, a bit more elaborated example about a stack that could be used in your push swap project as stacks. So here I created a type stack that is represented with a array that is much more effective than using linked list or something for a stack. So that's the way that C standard library implements it, and it's much more efficient. So you just need two attributes in this stack, right? You need an int pointer that you're gonna need to allocate. If you know the size, the maximum size of the stack of compile time, then you can put it there. But in this case, let's assume that we don't have, we're gonna receive from the user. And the int, that's gonna be an index to the top of the stack. Or the stack is gonna grow from 0 to n. Okay, and then we create two types for this stack that are gonna act more or less like constructors and destructors. And for those that are more familiar with objects, classes, and things like this. So first we have a function called create stack that receives the number of elements, and it's gonna encapsulate what is needed to create a stack. So first it allocates the pointer, the stack itself, and then it allocates the elements with the number of elements that you pass it. I'm omitting here the check if the malloc can fail, and it can fail. It's just for space limitations, but in your real function, you would check if the stack is null, then it, like if this allocation fail or this one, then it would return null. And but then you will be isolated in a single place. So no matter if you create in very different parts of your code stacks, the logic to create it, to allocate it, is in a single place. And the top is uninitialized. That is just a define to -1, because we're going to use the indices for the arrays 0 to n-1. So a negative number means that is uninitialized, but I use a define here just to be more precise. And then you could also have a destroy function that would receive the stack and would free the elements and then free the pointer. So then we are encapsulating again and destroy, rather than having free in your code. This makes it more clean, and it's a very good practice in my opinion. Then we would create like auxiliary functions for this stack. For example, function checking if the stack is empty, and returns a boolean because it's a question, yes or no, and receives a constant pointer because we are not supposed to change the content of the stack, because we're just checking if it's empty. And then what it does is just single line, it checks if it's uninitialized. That's simple as that. Then we could have a function called push that receives a stack that is non-const, because we are adding something there and a value that we want to add. So what this function does, is increment the top. So if it's the first element that is incrementing, it's going to go from -1 to 0. And then we set the index of that array to be that value, right? So that's very simple function push. It does what it needs to do, two lines, and you're going to distribute this with your stack, for example. And then you could create also other functions. Like here, I created a function called top. And for that, I've created also additional types. And I'm going to explain you why. So clearly, a stack can have a top or not, because if the stack is empty, there's no top, right? So you need to represent in the function, and you need to represent well how we're going to tell to the user that I can return something that is invalid, right? So the normal way is that you return a pointer, and if it's null, then there's no top. The problem with that is that if you want to return a pointer, first you need to allocate the pointer inside the function, and you return that function to the user, and then the user has the responsibility of freeing that pointer, which means like memory leak problems and all these kind of things. And beside that, every allocation that you do is time consuming. So if we call like this top many times in the code, it's going to be consume a lot of computational resource. So, but most importantly is about expressivity and making your code easy to use. Because if you need to free, the user might forget to free, and it's a hassle. So I create a type called optional int, because it has an int and a boolean saying if it's initialized. This is a type. Similar types you can find in other higher level languages, like in C++, for example. std optional is a bit different, but the intent is similar. And I tried to use something similar because I want to represent similar intent, right? So an optional, I would put two auxiliary functions to help the creation of these optionals, to make it easier for the user to create these optionals. So the first function is called create optional int, that receives a value that is gonna be inside that optional. And then I initialize the attribute value with the parameter that I'm receiving, and I'm setting that it is initialized. So it's a valid optional. And then I have another function called create empty optional int that receives nothing because it's supposed to be empty. The value I just put to 0 to don't leave it uninitialized, but this is like doesn't matter much. And then I set the isInitialized variable to false. So when the user is going to use this optional, it's going to check is initialized or not. So if you call the function top, it's going to check if the return is initialized, I do something, otherwise I do something else. But I don't need to take care about freeing that pointer if the top function will return the allocated memory, the pointer to the allocated memory. And then the function top would be like the signature would be return an optional int. So it's already a hint, a good indication to the reader that it's something that's optional. And it receives a const stack. And the code is simple. So if first I check if the stack is empty using the function that I showed you before. And if it's empty, I just call the function create empty optional int. That is this one, right? I don't need to like explicitly initialize the things here. It makes the code cleaner. And then if it doesn't return here, so it means it's not empty. So there is a top element in which I also create a variable to avoid, because this like includes the reference and indexing. So it's cleaner first create a variable to say like this means the top element. And I get this by indexing the elements at the index top. And then I create an optional int that is the function line 47, passing this top element. So the user could use easily this function and check the return to see if there was a top or not in the function, right? So this clearly shows an example, show like for the player and for the stack, how can you create additional types, additional functions, auxiliary functions for the types that you create, right? Okay, so another pattern that I see a lot people using is passing this so-called data or some type that has everything inside, and you just pass down from the higher level function to all lower level functions. In this case, it's a handmade example also, but I just got inspired by some examples that I saw, just to make it simpler for the code to be shown in this slide. So assume that we have functions like parse map, set player start position, set enemies start position, and all of them are receive game. And a game would have like a player, map, enemies, or all the things. And it's very common. I see a lot of people doing this. Like I just pass the game below to all the functions, and they use the types that the things that they want. This is a very bad pattern, and it makes the code very, very hard to reason about. It affects the readability and might lead to unknown side effects because you are passing the whole game to a function. Like this function set player start position could be changing like the enemies or doing something else because it's just having access to all the things. So a better approach would be to have the functions just receive what they need. If they need a map and a player, or a map and enemies, or just a map, you just pass what it needs to be passed, right? And then you don't provide the all or data or whatever. Just pass enough arguments for that function. And then if it needs too many arguments, it means that probably we're doing too many things in that function. Yeah, so no more than 3. 3 should be enough. So this is important pattern, and don't pass these data parameters around. Okay, we are approaching to the end. So we're talking about allocation. I see a lot of people doing memory allocations on the heap. Now, like in this example from ftprintf. So this is a high-level function from one example that I took from one student, and it has this type data, and it's a pointer. It allocates, and if it doesn't allocate, it returns -1 because it didn't allocate, and in the end it needs to be free because it was allocated on a heap. But this is not needed. This is a high-level function. I don't need to allocate on a heap. I just allocate on the stack. I declare the variable, and I just pass the address to the lower-level function. And because it's on the stack, when this function finishes, like when it reaches here, then the variable is going to be gone. You don't need to take care of the free. We don't need to take care of memory allocation failing or things like this. So in your functions, first you have a higher level function, and it needs to pass some variable that's going to be altered by the lower level function. You can create on the stack and pass the address, and then the receiving function points to that address and then modifies it if needed, right? It's a much better pattern. And lastly, one extra topic that I brought is called the dependency injection. It's a bit more advanced, but I think it's nice to give some small example about it. So this is an example that I created inspired on PushSwap, and you have like a type instructions like PA, PB, SA, whatever, and you can have like also definitions for end of instruction or invalid instruction, right? And let's say that you have a function that is process instruction list that's gonna like be on while true, for example, reading from a standard input using, for example, get next line function that you wrote, and processing until reach some invalid instruction or end. The problem with that is that you depend on the get next line, which depends on the standard input. So to test this function, you need to probably create a main and write a bash script or a Python script, or even worse, type the things that you want to try like manually. So it's very hard to test, hard to automate, and that's what I want to address here in this slide. It's like the idea is that we inject the dependency of, and the dependency here is how we get an instruction from the user, from the input, right? Is if it's a PA or PB or something. And the dependency is the function that's going to get that standard input. And for that, I create a type def that is a function pointer. And it's a very ugly syntax in C. I acknowledge that, but it is what it is. So the syntax is the following. So this is a function pointer to a function that receives no parameter and returns a instruction type. So this is how you read. So it's a type def for a function that returns a the instruction. The name of the function pointer is this part of this syntax pointer, and then t get next instruction. So this is the name of the function pointer, and these are the arguments of the function pointer. So you're gonna have a type that can point to any function that satisfies to this signature, right? And then in your function process instruction list, you could receive a function pointer, and you call it like next instruction, and that is gonna give you the next instruction. And for the purpose of this function here, process instruction list, it doesn't care where this next instruction comes from. If it's from the standard input, it's from the file, or from whatever, that doesn't matter. So then to use this function pointer, you just use the parentheses here, and because the function pointer points to a function that doesn't receive anything, so you just empty. And then it returns the instruction, and then you do whatever it needs to be done, process next instruction, so on and so forth. So then you could test this function. How? You could have two versions of a function called get next instruction that we're gonna pass point to them whenever we wanna test or not. So the actual function is get next instruction that gets from the standard input using get next line, for example, and then gets this the string and then convert to instruction and return. So this is the one that you're gonna use when you submit your project, for example. But you could have another one called that get next instruction set test, that you could write a test in C, that you don't depend on anything external, don't depend on manual intervention or anything, that is gonna just have a given set of instruction that you wanna test, right? And to achieve that, it uses static variable in line 33. And for those that are not, don't know about static variables, in a function, they are just variables that are initialized once in the lifetime of the program. So the first time that this function is called, it initializes the I to 0. The next time, it's gonna keep like memory from the previous time that it was called. And then we have an array of instructions that can be anything. You can create your own. Like let's say that I want to test this following set, like PB, SA, PA, and then end of instruction. And then this function is gonna return the instruction pointed by the index I at that current. So the first time that you call this function, it's going to initialize it to 0 and return list 0 and increment the I. And then the next time, it's gonna not gonna initialize again, and then I is gonna be value 1, and then it's gonna process SA, then PA, then an instruction. So then you could use this technique to test your code, or for in other case, you could make your code more reusable. You can pass inject some dependency to make some function more reusable, and just injecting some specific step, and the high-level steps are the same, right? Okay, so now the conclusions. So we talked about clean code, and as you could see, it's a lot about good naming, being expressive, and as you could see, and as I can tell you also, and you can talk to like other developers outside that are in the industry, clean code improves productivity and makes the life of the reader or the maintainer much easier. It's much better quality. And remember that the code is written one time and read many times. So you write your code for the reader. So it's like a normal writer. You don't write a book for yourself, you write the book for the others. Then you need to think about your reader, the people that are gonna maintain your code, even yourself in the future, right? So, but there are, like I said and stressed at different times, so there are different ways of writing clean code. You find your own way, you practice, revisit this presentation, revisit your projects. Try to practice. Is something that takes time, but is worth, and it's gonna be very important in your future career. Because yeah, now you are working like a project alone, or maybe one or two students, but in your future career, you're gonna be working maybe with hundreds of people, right? So it's very important that you practice clean code and improve this skill that is so valuable for the industry. And for example, when you collaborate with hundreds of people in your future career, it's gonna be much easier. And you can use this experience in Codam or other 42 branches to practice clean code in your evaluation. Ask the reviewer if he thinks that the code is good or not. And yeah, I really encourage you to revisit your past projects, practice in clean code, and think about your future career. So a few references, some more advanced, some more basic. So these first two, I really recommend like reading Clean Code from Robert Martin, aka Uncle Bob, a handbook of agile software craftsmanship. So it's a good book to read, not very advanced. There might be some chapters more advanced, but you could skip for now. Also, The Art of Readable Code. These other ones are a bit more advanced, but those that want to take a look, The Art of Unix Programming talks about the history of Unix and the simplicity and the clean code and things like this. And I also encourage you to look at this YouTube presentation called Coding at a Better World Together. It's a 2-day live stream presentation from Uncle Bob that was organized by Rabobank in 2019. You can easily find on YouTube. It also talks about clean code, and it's a very easy language, and it talks about some advanced topics, but the language that he uses is very simple, and then everyone can benefit. Right? So thank you very much for your attention. I hope that you all enjoyed the presentation. And yeah, we're gonna have time for questions. So the first one that I have here, what do you think of the school norm guidelines, 25 lines per function, 80 characters per line, no ternaries, no variable initialization? Okay, so first is to make clear that companies, sometimes, yeah, in the case of 42, they have norms and guidelines. You can find guidelines from Google, you can find from Facebook online, you can have a lot of these things. And they vary. I think that I like, for example, the 25 lines per function, although, yeah, sometimes wouldn't be bad if you exceed it, but I understand the rationale behind to force you to try to refactor into more functions. But on the other hand, I know that there is a limitation of 5 functions per file, like even in a .c, and this makes harder to achieve these 25 lines per function, because if you want to decompose your logic into like 6, 7 functions, then you need to, because you have a limitation of 5 functions, you need to create another function, another header file or another source file for something that would be internal, like a static function. So I understand the 25 lines per function, and I think it's nice to enforce. In general, there is no such like hard limitation, 25 lines, but I like this just to enforce you to try to write smaller functions. 80 characters per line, this is a very old guideline that many companies used to use back then with those CRT monitors of 14 inches or something like that, and he wanted the line to fit in the screen. Of course, nowadays we have like wide screens. I think 80 characters is not, yeah, it's too little, it's too conservative. I would go for 120 for something like that, right? You don't want to go much beyond that, but 120, because if you want to write good variable names like descriptive, they take space, right? They consume characters. So I think 120 up to 140 is fine. Ternaries, I think in some conditions they are good because they let you like initialize a variable constant in the same line, things like this. But yeah, maybe they want to force, I don't know what's the rationale behind, but they want to like encourage you to write in a different way. No variable initialization, I completely disagree. This is like an old guideline from C programmers, structural programming, and I saw this in other companies that I've worked on. And there was no mandatory, but it was very common. And it has many problems because you separate the variable too far away from its usage. You should, in general, I prefer to put the variable closer to the to its usage, right, and initialize right away. So I don't agree with this one. No assignments in if or inside the statement itself. I agree with that. I think it's not good. So if you do if I equals something, it's bad. So I don't like this. So I agree with this norm. No for loops. I have mixed feelings about this norm. I understand what they are trying to achieve, because when you use a for loop, sometimes you don't think about what is happening behind the scenes, right? That you initialize some counter and you iterate, you increment that counter if you are doing like increment, and then you have a stop condition or something. Then you use they force you to use the while so that you really understand and internalize what is what the for loop does under the hood. That's in a while statement. So I think it's fine using while statements only. Okay. Next one. How do you find the balance between optimizing the beginning and optimizing later? There's a saying that optimization is the root of all evil. So don't pre-optimize. Premature optimization is a maintenance hell, and you can find tons of talks online, books, and people talking about it. Don't over-optimize. First, because the compilers nowadays, they are very smart. Truly, they are like a piece of magic, and I'm always amazed of what these guys can do, like Clang or GCC, but there are also the Intel and the Visual Studio, but talking mainly about the main used ones that are GCC and Clang, I think. And they do like amazing job, not only for optimizing your code for you, but also for warnings and helping you like writing good code, because they can find things that you write in your code and that can cause problem. So I really encourage you to trust your compiler to enable all the warnings and things. So about the optimization part, I think is important is that you write your code clean, modular, that is not like a spaghetti code that has every function, every part has its own responsibility and things like this. And then, for example, in the end or at some point, you're going to measure. So to optimize, you need to first measure. There are tools for that, like Valgrind, and other proprietary tools. Valgrind is free, by the way. And then you can run the code with some inputs or set of inputs, and then identify some bottleneck, right? And then from the bottleneck analysis, then you see like, yeah, this function is consuming like 60% of my time. Then I can optimize it. Right? But first, you need to have a good code that it makes it easier to measure. So the key here is writing clean code and measure. And then with your measure, with your data in hand, then you can optimize. And I see like many times, also in courses that I took in the past, and people saying that sometimes you're in a company and then there's a bunch of very smart engineers, experienced, and they think, yeah, I'm not going to use the standard one provided by the library. I'm going to write myself because it's better. They never measured. And then after a while, after 1-2 years, they spend a lot of time developing a new library, developing a new container or something like that. And then they measure and they end to be slower. So the important message is like, don't do premature optimization. Think about separability of concerns, one responsibility per function, make your code clean. And then later, if it's something is slow, you measure it, and then you optimize that specific part. How to cleanly manage errors at the program level? Well, I'm going to address this in C, right? Because C, there's no exceptions. So I'm going to answer this question from the point of view of C. So in theory, a function per se should be something that you have parameters that are inputs to the function and the returning thing, return a value that's going to be something returned from the function. I understand that sometimes, for example, if you want a function that do something and it can return an error, but you also want to get something else out of this function. There are different ways of achieving this, and I'm not saying that this way that I'm describing is the best. It's just my preference. I particularly don't like passing input-output parameters, like or output parameters only. Like, let's say that you have a function that computes something and has to return an error and the result of some operation, like a calculator or something like that, right? The return of the function, in general, people would do like return an error type that would be represented by an enumeration, for example, and receive like an int pointer. that is going to contain, that the caller would allocate or pass a reference to a stack variable, and then the function would write the result there. It's okay. I prefer to do it differently in general. I prefer functions to get only in parameters or output parameters as an argument I don't like. So what I would do instead, for example, I would create a custom type, for example, response type or something like this, that would have an error and an integer, in this case of the calculator that I have described. And then your function returns the integer and the error. And then the caller would check, yeah, if there is no error, then yeah, I display this, for example, this result in my screen. That's how I would do it. And I would avoid, even if you, yeah, sometimes you might need to pass the pointer because you allocate the memory somewhere else, but vast majority of the cases, you don't need it. So you can just return a single value, a single type that contains like a pair of your error and the value that you want to return. Leaks are a sign of clean code, but what about freeing your allocated memory before exiting? Not clean code, okay. Of course, you need to free your memory, of course. The problem of the allocating memory is that, for example, when there are errors or things like that, you need to identify and properly clean your allocated resources, no matter if it's memory or if it's a file descriptor or something like that. So yeah, you can like clean up your allocated memory, but it's important that you just allocate what really needs to be allocated. And if you can, if you are in a given level in your program, if you are in a given scope in which, let's say that you have a top level function, level 0, and then you call a function in the lower level, let's do it the other way around. So you have a higher level function 3, and then calls a function level 2, and then which calls a function level 1, right? So if you have to allocate a stack, a variable on a heap on level 3 that is used by all the 3 levels, then there's no other way. You need to free here, or have some error handling to free it in the inner functions. But then in this case, you clean the leaks in the higher level function. But for example, if you allocate this variable in level 2 or level 1, then you should deallocate in that specific level, not in the level above, right? Should each C file in a project have its own header file, a few header files for the whole project, or something between? Does depend on the project? Yeah, every header file, every C file should have a header file, in my opinion. Of course, there are some exceptions. In programming, there are no like rules set on stone, right? You need to. Some cases there might be things that you can have a single header file and multiple source files. That can be, but in general, you can split it. So in the example that I did for ftprintf, so you saw that broke down like the header of ftprintf would have only the prototype of the function that was being exposed, right? Or for example, in the cube project, you have player, map, parser, enemy, whatever. So each one should have a header file, a C file, and the types and the auxiliary functions that are going to help creating and destroying the types whenever needed. How do you keep the overview of your project in that case? Yeah, it's much easier to keep with many header files than with only one, right? First, because you understand better where some things being used, right? Because the only files that are going to include a header file are the ones that really need that resource. So it's easier to have a graph of the usage of your header files or your library of your functions or things like this. So, but that's fine, and it's normal to have like sometimes you have let's say they have 20 header files. You can break down in folders, like that's again to the cube project. Have, for example, let's say you have player, map, parser, like many other things like recaster or things like this. You can have structure your project like in the root of your project, you have maybe your make file, and then an SRC folder, for example. And then inside the SRC, you can have a player folder, a enemy folder, a map folder, a parser folder, things like that. And then inside, you have only the things that belong to that. You're breaking down your project into parts, right? Organizing your project in directories or modules, depending on if it's another language, but talking about C. So then you manage the complexity of many header files and things like this. In example, used with enum key left, arrow key right. But wouldn't it be better to use key arrow left, key arrow right? You can organize in alphabetical order. I didn't think about it, to be honest. You can organize in the way that you think it's better for the reader. As long as it's an enumeration and the namer describes well, you can, can have different ways of organizing this. As you organize the includes, for example, I tend to organize my includes in alphabetical order because for me it makes easier, and also in many companies they also have this this guideline, and yeah. Let me see. What clean code should I first improve as a beginner programmer? It's hard to say. So I would suggest, get one of the books that's a clean code from Bob Martin, look at the presentation. And the key here is to practice, right? It's something that you're gonna practice and practice and practice. I keep practicing, I keep improving. And that's the thing, right? Of course, the main thing that comes into my head is the naming, right? The naming is what expresses your code, the name of your variables, the name of your functions, things like this. So you should improve your naming for variables, functions. And I encourage you to, if you have done some projects, or if you're gonna do, take some parts of your project and think again, rewrite it as a clean code, try to improve it, and then you're gonna practice and get better with time. There's no like secret sauce, you need to practice and think always about your reader. Okay, what clean code should I first approve? Is the same question, so it's kind of answered. Is needed and or useful to set to null a free pointer? You can set. It's better. It's more like expressive. But again, so in the example of the type of the stack, for example, you could set the pointer to null, although it was an input pointer for the function. But you can free and set to null, no matter. But the important thing here is encapsulate these things whenever possible in functions that are gonna be responsible for allocating and delocating your resource. How to name files and structure in a project directory. So I gave an example about the cube. So I'm gonna repeat because maybe some people didn't get it yet. So the idea is that you need to, and one important thing before is that these things, they are not things that you're gonna find the best thing in the first shot, right? Sometimes you're gonna, programming is the art of learning and iterative learning, right? You're gonna do a bit, learn a bit, like let's say that you write a function, you don't know very well how to do something, and then you write a function, agree code, that's fine, and then you, okay, now I understand what it needs to be done, because you put your ideas on paper, and then you refactor, improve it, and things like that. You should also test it. Which could be a subject for another masterclass or workshop. But yeah, so come back to the structure. So in the case of cube, you'd separate the concerns, like the things that make sense to separate. So let's say that in the beginning you have this source folder that's in the root of your project, and then you create a directory for a game and another directory for parser. And then you start growing your project, you realize that the game has player, has enemy, has recaster, has many things, and then you think, okay, then it's getting too big. Now I'm going to create 2 more directories. One's going to be game, another is going to be player, another going to be enemy, and then parser, right? And then you keep going, and then later on you figure out that, yeah, maybe I should create another one or merge 2 that I thought that it would be separated. So the rule that you should use for creating directories in general can be, in some sense, similar to why you separate a header, like it's a different level of abstraction. So you're talking more about project level. So these 2 things should be close together or separated.
Vinny,
yeah.
I'm just aware of the time. Shall we interrupt it right here, and we're gonna just take the questions, the remaining questions, and maybe you can create a document and you can tackle them in 1 or 2 sentences, and I could share it with the students.
Yeah, I can, but I can do more 5 minutes. Or if you want to interrupt, that's fine to me as well. I can address them later.
I just noticed, yeah, so we are at the very constant amount of viewers, so maybe we could take another 5 minutes. How about that? Okay.
Okay, yeah. So how to name files in structure, I just answered. Would you recommend functional programming style to be more declarative, so easier to understand? Functional programming is hard. It's very nice, and it's increasing more and more its usage. I recommend like learning. It tends to be more declarative in some point. Sometimes it's harder to understand for those that are not familiar, but it's more about immutability and variables that don't change. And it's come in the direction of using constants, right? You want things that don't change. And these are, the functional programming style assumes this as per se that things are immutable. But I think you can practice clean code and declarative code in structural programming, object-oriented programming in any paradigm, right? So if you are still learning structured programming or you're in the C curriculum, practice more in C because you are more familiar. If you can add another language but don't just ignore what you have been doing. You can learn as a like side project or something that it's always going to add, of course. What do you do in future careers when one encounters legacy code to by no means falls? Yeah, it's legacy code is a hell, right? It's very complicated and it's common. Some companies have more, some companies have less, and that's a reality. So there are different tips. So there are, I cited a book about refactoring. It's from Martin Fowler. You can read that when you have time. But I first practice in your career, in your student time now. And when you encounter, yeah, it depends from company to company, but in general, it's important. And the companies are now realizing this more and more, that legacy code draws the productivity and keeps adding recurring bugs and things like this. So companies are investing more in improving their code base. For example, Google, if I remember correctly, they rewrite their entire code base every 3 or 4 years. So of course, not all companies can do that, but they should always, and it's not about like a specific language or version of the language. It's about how you write your code to be modular, to be maintainable, testable, and things like this, right? So yeah, you can practice about refactoring legacy code, looking at some books, and be prepared to encounter some of them. It's normal, but in general, so if you have a legacy code, and what I used to do, like for example, I had a lot of C legacy code in the previous company, and I would isolate the function, all the legacy part behind the header, and then I would just use that and don't touch inside, and then write the new code or wrap it around or things like this. One more question. What about making the key macros? I don't like macros. Macros are evil. So they are pre-processing time, and you can have weird problems. Like I really, especially functions in macros, you should avoid it. With declaring types, you saw that I've done for true, false, and uninitialized, which is, in my opinion, still okay. But key macros, I don't like it because the keys have a meaning together, right? They have a meaning per se, and they make sense to be together. So it's much better to use a type for that, because a type, the compiler helps and understanding and reporting errors and things like that, and it's more expressive. So use enums. And subject of comments, what about automatical documentation? Yeah, I've a lot of experience with Doxygen. To be honest, a lot of companies enforce that, and I think it's completely garbage because nobody reads it. I see no one opens like a page of a documentation that you're going to navigate in class diagram or look at the function, right? So that's my view, and also, even if people did look, in general, those documentations are out of date, right? Because people don't update the documentation. So some libraries do that, like for example, Boost and things like that. Then they can do it, but in general, I think it's better to write it good code. When you write a big program, how do you document the working program? Meaning how functions work together. Or something. Yeah, like I said, the comments you can add for things that cannot be expressed in code, right? And the program, yeah, there's no secret sauce. Like programming, software engineering is like iterative task. You learn, you need to learn, you write a little, learn a little. And for testing, you write a little, you test a little, you write a little, test a little, write a little. So for those that are interested, and I strongly suggest to search a bit about topic test-driven development, unit testing, these kind of things. It's very important. And this helps you grow in your program in small steps, right? So you don't write a big problem in a big shot. Of course, you can have a sketch about the structure. So I'm going to organize this more or less like this, but not set on stone. It's something that you're gonna learn, right? See, is there something else? Is garbage collecting algorithms, for example, collecting algorithms a good practice? Yeah, you can have a library with your containers, I assume, right? And for example, you have a linked list, you have array, you have like a standard library in C for C++ for that has vector, hash map, that's called an order map, hash set, things like this, right? It's fine. I'll try to address the other ones with one vote. It's garbage collecting algorithms, good practice in C. Don't use linked list. That's my suggestion. So linked list, it's a very bad data structure. In some cases you can use it, but you should only use linked list when you must, because linked list lets you insert in any point of the list, right? And like a contiguous structure, like that's a random access container, like an array, you can do it, but then you need to relocate the memory sometimes and move the elements. But to be honest, I found a rare case in my career where I had to use linked list. And my current work, I had never used linked list. Most of the cases you can use a vector or create some abstraction on top of vector. Like for example, C++ standard library has a double-ended queue in which it creates an abstraction using vectors to create a queue that you can insert in the end or in the beginning. So linked list is not a good structure because you need to understand, you need to learn. That's perfectly fine. But it's hard because you get lost with the pointers, spaghetti, and you forget to point here, there, things like this. But also from performance point of view, it's very slow. Even if you pre-allocate all the elements in the linked list in the beginning, which sometimes is not the case, you also have the memory access pattern from the compiler, from the processor that hits your performance. And because your processor and your computer architecture takes benefit of linear memory access, and then linked list is scattered in memory, right? So then the processor pays a big penalty because it cannot find the next piece of memory, the data that it wants, not in a piece of memory that's close to the processor. Then it needs to get in another level of memory, and then it increases the order of magnitude by 1 sometimes, or more, or 2. So learn linked list, know how to use it, but avoid it. When you write big, yeah, I think I addressed most of the questions. So, yeah, good.
Thank you so much, Vinny, for sharing your knowledge. I find it amazing how humble the developer community is, and how, you know, you guys, after like years of working, you know, in the industry, you always want to give back towards, you know, younger software engineers.
Yeah.
Thank you so much for taking the time for this. By looking at our comments overall in the chat, I mean, it's been fantastic. Like, the students truly appreciated the knowledge that you shared, and they started understanding even more the importance of clean code and how to actually do it.
Yeah, I'm really happy for that. Of course, I spent quite a bit of time preparing the presentation and trying to find good examples and bring examples that are in encompass with their current life. That wouldn't be nice to bring like abstract examples. So I wanted to bring concrete examples so that they could apply on things that they have done or they would do.
It was noticeable, and
I'm really happy for that. That people enjoy that and can watch it later, and we can see. I can provide the slides later for you if you think. But
I would appreciate.
Yeah.
I would appreciate it. We will also create edited version of this video, and we will share it again with everybody. Actually, one of the most written comments was that they should have had this class, you know, at the beginning of their curriculum. And actually, this is something that I was chatting with David Giron, the director of Codam, in the chat. And guys, the idea is that you need to first understand the importance of clean code. So you need to go through the pain of like doing bad code and see what's a bad code. And then, you know, like maybe later on, after like 4, 5, 6 months, you know, then to watch this video. But the idea is that you learn on your skin, right? Because you're going to share code between each other. And if you do not understand what on earth you wrote.
Exactly. Yeah, encourage also the students in the code reviews, in the project reviews, to focus on these things, right? Don't focus on side things. Focus on trying to understand the code, asking, why did you write the code in this way? Of course, it might not be a reason to reject a project because of that, but just like, yeah, maybe you could have written this function differently. I don't understand what you mean by that. So really discuss this. This is important from a project review point of view. So take this into account, and you're going to learn a lot.
Yeah, indeed. And thank you for being brutally honest about our own Norminet.
No, like I said, every place has a norm, and I understand there are always reasons, and you're never going to like satisfy everyone, right? That's fine. Just my personal opinion is that some norms should be revisited, because the reason is that I understand that some norms are there to enforce the students, like, for example, the while. You cannot use the for loop because you want to learn better how a for loops works, and then you use a while. But for example, some norms like initializing, do not initialize the variable in the same line. I think this is not good, in my opinion, because like programming, it's like any other activity. You create some vicious things, and then later on, it's hard to get rid of them. So then you start learning something that is a practice that nobody does anymore or shouldn't do. So then that's my main critique. Is not because I don't like the thing per se. Is that it's not used like this a lot, at least not from my experience. And just to avoid the students to say that they are doing the same thing for 2 years, and then they go to the industry, and then they need to really learn again how to write these things because it's so automatic. So that's the main point for me.
Yeah, so the point of the master classes, these are not per se lectures. This is basically taking the knowledge from the industry and showcasing to the students. But so with this purpose, I want to remind to the students once again, Norminet is still something that, you know, is compulsory in any 42 campuses. So please, you take, the best practices that Vini brought to you, but when you submit the assignments, please take into consideration the Norminet. Currently, it is what it is. Maybe it's going to improve later on, but for now, please
exactly.
follow the internal regulations.
And then if you want to make your life easier, try to always, when you write the code, make sure that it's always satisfying the norms. Otherwise, you're going to leave the pain all to the end. So then it makes like annoying that you are working for 2 months, for example, in a project, and then you need to spend like 3 days putting on the norms. So do it on the way, like check it constantly, then makes your life easier. And regarding what norms are good or not, then just my opinion, and you guys can trigger the discussion among yourselves. And it's always good to have discussions and measure the pros and cons of everything, and then you judge what's better or not, right? But yeah, for now, follow it for your projects, and yeah.
And just last bit of the session, I want to ask you, like, what would be one thing that you would recommend to our students or advise our students? And it can be beyond the clean code, it's not per se, but they are the young, talented software engineers, right? Mm-hmm. So from a more senior person that went already through the for a career in software engineering, what would you suggest them?
And there's not a single thing. So I think be humble. You always have things to learn, especially in this area, because technology, every day there are new things coming, different languages, different things. So you always keep your mind open to learn and try to keep up to date, learn things, watch videos, read books, these kind of things. And I think practice clean code is something that is going to help you in your career, no matter if you work on web or embedded systems or whatever. You can write clean code in any language, right? So this is very important characteristic, and many companies consider that. And the ones that don't consider yet, they are realizing, because it's expensive to maintain bad code. It costs a lot of money. So it's some important trait. And another thing that I suggest the students to look into it is about testing, like test-driven development. We could think about another class or workshop, but I suggest them to look at some of the references, find books, and practice it, because it's, from my point of view, the most important concept of software engineering is test-driven development.
You know what? I'm going to follow up on this, because now I have it on tape. You suggested that we should do another masterclass on testing. Was this right?
Yeah, we can do it, but to be honest, I'm not sure if for testing, the best format would be masterclass, because maybe a workshop or something. We can discuss it later, but you can also find a lot of material online. There's a lot of good speakers. You can just test-driven development, put on YouTube, find books, things like that, to understand a bit more. But it's something that I think would work better on a hands-on. Right?
One way or another, I still would like to involve you somehow later on. So let's keep in touch. Thank you again for the knowledge. And guys, best of luck with writing clean code. We watch this video 1,000 times until you actually have clean code.
Yeah, thank you.
Bye.
Bye.